Okay, so now here's another example. Again, we're going to solve the system through substitution. Okay, again, we're just looking to see where the two lines cross, but we're not graphing them to see where they cross. We're using substitution. You'll see that in this example, both equations are in slope-intercept form, y equals mx plus b. Obviously, you could put the plus 0 here, okay, and that would be your y-intercept, and your slope, of course, is a 1. There's always a 1 there. If you don't see it here, the slope is -1, okay? But you don't have to put the plus 0. Hopefully, we just know at this point y equals mx plus b. There's a plus 0 there if there's nothing. Okay, so now I'm going to use substitution. You see here, this equation tells you that y equals an x, or 1x, okay? This tells you that y equals -1x plus 2. Well, if both of these equations are telling you what y equals, that means that this 1x is the same as this -1x plus 2, because they both equal what? Y, right? Because y equals this and y equals this. So it's like if I said 5 equals 1 plus 4 and 5 equals 2 plus 3. Okay, well, 5 equals 1 plus 4, 5 equals 2 plus 3. So can I say that 2 plus 3 equals 1 plus 4? Yes, I can, because they both equal what? 5. Okay, so both of these equal y. So I can say that 1x equals -1x plus 2. Again, why can I say that? Because 1x equals y. This is y. And then -1x plus 2 also equals y. Again, this is y. So if this is y and this is y, we know y equals y. It's just like 5 equals 5 or 2 equals 2 or 7 equals 7. They're the same thing. So you can set them equal. All right, once you've done that, you're going to solve. Now remember, way back, you have letters on both sides here. I referred to it as lobs, okay? So letters on both sides. You can't solve when you have letters on both sides. You have to do something first. And what you have to do is pick one of the letters to get rid of. How do you do that? You add the opposite. And if you remember all of that, hopefully you remember that I always said don't get rid of the lonely letter. See how this 1x is all by himself? He doesn't have a plus 2 like this guy. So leave him alone. If you decide to get rid of him by adding the opposite, you'll cause yourself extra work. So let's get rid of this guy. He's not alone. He's got a plus 2. So you won't have extra work. How do you get rid of -1x? You add a positive 1x, right? So now he's gone. But of course, you have to add the positive 1x over here. 1x plus 1x is 2x. Bring down this plus 2, and then solve. It's just a nice one-step equation. These are attached through multiplication, so to get rid of it, you will divide, and you'll get x equals 1. Now, you only have half of your ordered pair. You know a solution is an x comma y. So now you need the y. What do you do? Well, you're going to go ahead and replace x with what you just got for x, which is 1 in the first equation. So instead of y equals 1x, I'm going to do y equals 1 times 1 because I think my x is 1. So, of course, that just means y equals 1. So I think that's my answer for y. But now I got to check my solution. Okay, you got to check this. How do you do it? You look at the second equation and you replace the y value with 1 and you replace the x value with 1 and you see if it's true. So instead of writing y equals, I'm going to see what y is, it's 1, and I'm going to write 1 equals. And then instead of writing -1 times x, okay, -1 times x, I'm going to write -1 times 1, because that's what x equaled. And then the rest of the equation plus 2. Okay? Now see if the sides are equal. Of course, here you're going to multiply first. See the parentheses. -1 times 1 is -1. Bring down the plus 2. Bring this down. Bring this down. Is -1 plus 2 1? Yes. So your solution is correct. You just checked it, and everything is good.